Raise your hand if these 6-fold lines appear to be converging. That is actually incorrect. The 6 folded lines that you are seeing are actually parallel. As each crosshatch is removed, you can see there is clearly no convergence of the lines, as they are each equidistant and tilt at the same degree. In order to create this illusion, we added a number of crosshatched lines over each parallel line and switched the direction of these crosshatches on every other parallel line. In doing this, the lines appear to converge at one end as the other end appears to get wider. This is known as the Zollner illusion.
The creator of the Zollner illusion, Johann Carl Friedrich Zollner, was a German astrophysicist who discovered the optical illusion in 1860 while studying the pattern on a piece of cloth. He shared these findings with a friend, J.C. Poggendorff, who discovered a similar visual illusion, now called the Poggendorff illusion. The Zollner illusion is defined as an optical illusion in which long parallel lines appear to diverge or converge when crossed by rows of short, oblique lines. As you experienced for yourself from the demonstration at the beginning, lines that seemed to be converging due to smaller strategically placed lines were in fact parallel. This became clear as the smaller lines were removed.
According to a study done by Koo and Kim, titled Using the Kinetic Zollner Illusion to Quantify the Interaction Between Form and Motion Information in Depth, spatiotemporal characteristics and object form play a part in approximating motion. Form and motion information influence our ability to detect motion. Form-sensitive neurons integrate information over a short period of time, and therefore the image of an object is smeared along the visual receptive field and produces a motion stream that moves away from the object. In this illusion, the background lines change the orientation of the motion stream, in addition to the production of a motion detector, causing the perceived detection of motion to be distorted.
Koo and Kim also touched on how depth plays a part in how we perceive the Zollner illusion. The fact that shorter lines are on an angle to the longer lines may help to create the impression that one end of the longer lines is nearer to the viewer than the other end. Go.
Global mechanisms, which include acute angle expansion and acute angle contraction, occur in V4, or higher areas that code object form. Local mechanisms, which include acute angle expansion, can be found in visual area 1, when the induced line is real, and visual area 2, when the induced line is illusory. In the primary stages of visual systems, the location of small regions are detected, which are then inputted into higher cortical areas. Local expansion illusion starts first in V1, and global orientation detected by V4 neurons shift towards expansion. After this, global expansion and global contraction mechanisms interact with global orientation and determine the final orientation shift.
A study done by Watanabe, Nakamura, and Fujita, looking at the effects of the Zollner illusion on pigeons, found that pigeons do in fact have a perception of the illusion, but one that is opposite of humans. The pigeons in the study selected the gap that humans perceive as wider as narrower for them. This indicates that the pigeons are actually perceiving a reversed Zollner illusion. A similar article by Agrio, Parrish, and Baran studied if a type of monkeys, the rhesus monkey, could also perceive the illusion. If they are able to perceive the illusion as humans do, they will select the same gap, the wider gap, as humans when looking at the illusion. Rhesus monkeys did in fact perceive the illusion in the same directions that humans do, as opposed to the reverse way birds view the illusion. The 30-degree crosshatches cause an increase in the perception of convergence between the two parallel lines.
Zollner illusion is an optical illusion in which long parallel lines appear to diverge or converge when crossed by rows of short oblique lines. Motion information influences our ability to determine motion and has important implications in vision, specifically identifying where textures, objects, and surfaces are in the visual world. The interaction of form and motion occur across depth and are tuned for binocular disparity. Depth also influences the way we perceive the Zollner illusion, due to the way the lines are projected onto our visual field. Angles are also thought to have an effect on the way we perceive the Zollner illusion, due to the way our brains process angles. When looking at angles, the brain may exaggerate how acute angles are perceived and underestimate how obtuse angles are perceived. The brain tries to alter how the angles are viewed and creates an illusion of the longer lines being slanted.
Potential future directions for research on the Zollner illusion include the question of how old a human needs to be in order to perceive the illusion. Are infants capable of seeing the illusion? We are also interested to see if gender has an effect on how humans perceive the Zollner illusion. Finally, the study done by Koo was the first to look at the interaction of form and motion in neural models in a 3D space. Future research could elaborate on how the visual system determines motion.